Let's practice solving a quadratic equation application problem dealing with projectile motion together. In this problem, we have a tennis ball that is being launched directly upward at a rate of 64 feet per second from an 80-foot tall platform. The equation for this tennis ball's height is going to be represented by h as well as t, and is going to be this function of h of t is equal to negative 16t squared plus 64t plus 80. This rate or velocity of 64 feet per second can be found in the equation as this coefficient right over here in front of that t. And since we know this tennis ball is being launched from a platform that is 80 feet tall, we're going to have a constant at the end of our equation here of 80. Let's see if we can visualize this a little bit better. Here is our y-axis, but this is going to be representing the height of this tennis ball. And here is our x-axis, which is going to be representing time. This tennis ball is going to be launching from an initial height of 80, so I'm going to go ahead and write 80 as the height on the side over here along the y-axis, and the tennis ball is going to be starting from this height. So the tennis ball is starting at a height of 80 feet and it's being launched upward, so it's going to go up for some time, then gravity is going to cause this ball to then drop, and eventually it's going to hit the ground maybe somewhere over here. As you can see, we have a parabolic shape here and we have this whole parabola opening downwards, and that's because we have a negative coefficient here of negative 16, so we know the quadratic equation or the parabola is going to open down. Now let's see if we can go ahead and find the maximum height of this tennis ball. Looking at our picture above, we can see that this point up here is the highest point that the ball reaches. If we're going to go ahead and find out this maximum height of the tennis ball, it's going to be really helpful to figure out when that's going to happen so that we can figure out where it's going to happen. Now try to think back and remember that this vertical line that is in the middle of our parabola is represented by something called the AOS, or the axis of symmetry. For this particular application problem, this is the time at which the tennis ball is going to be at its maximum height. Let's try to see if we can remember our axis of symmetry formula. Now it's going to be x is equal to the opposite of b all over 2a. Now for the context of this problem, we're using t to represent x, so this is going to be the time is equal to, and we have the opposite of b. Now b is equal to 64, so we're just going to have negative 64 as our numerator, and in the denominator we have 2 times a. Now a is equal to negative 16, so 2 times negative 16 is going to be a negative 32. Now simplifying this a bit, negative 64 divided by negative 32 is going to be positive 2. What we just found out here is that when t is equal to 2, or when 2 seconds go by, this is when the tennis ball is going to be at its maximum height. Let's go ahead and take this function and replace t with 2. Plugging in 2 wherever we see t in our function, we have 2 squared, which is going to be 4. 4 times negative 16 is going to be negative 64. Then if we go ahead and see this next part, 64 times 2, that's going to be plus 128. And then finally we have this plus 80 at the end. Now negative 64 plus 128 is positive 64, and positive 64 plus 80 is going to be 144. So this is going to be equal to 144. And so what we just figured out is that h of 2, or the height at which time is equal to 2, is going to be equal to 144 feet in the air. That's going to be the maximum height of this tennis ball. And so we can go ahead and conclude that when t is equal to 2, or at 2 seconds, the max height, or h of 2, is equal to 144 feet. Now let's take a look at the next part of the question. So for part B, the question is how many seconds will it take for the tennis ball to hit the ground? Now let's take a look at the second question. For this one, the question is how many seconds will it take for this tennis ball to go ahead and reach the ground? Now remember, this tennis ball did start 80 feet above the ground on a platform, and it was thrown upwards, and then it came back down, and eventually it was hitting the ground right over here. So this location on the ground is going to be where the ball is hitting the ground. So how are we going to figure that out? Well, take a look and notice that at this location that h is equal to 0, right? Because it is on the ground, so the height is 0. So let's take a look at our original function. Now the question is how many seconds will it take for the ball to reach the ground? So we're looking for t, which means we must know what h of t is. Now h of t is just representing the height at that given time. Now when it hits the ground, we know the height of this tennis ball must be at 0. So let's go ahead and replace h of t with 0, because that's really just the y value at that given time, or the height. So we're going to say 0 is equal to this negative 16t squared plus 64t plus 80. Basically, we're now just going to solve for the t value that tells us when the ball is going to be on the ground, or when h of t is 0, or the y value, which is just the height. Hopefully this looks familiar because this is just a quadratic equation written in standard form. We can try using any of our 4 methods of solving by square roots, factoring, or completing the square, and there's also the quadratic formula. Now, some common factors we have are 1, as well as 2, as well as 4, 8, and 16. Now, we should factor out the GCF to make our lives a little bit easier. Let's factor out a negative, so we have a leading coefficient of 1, so we have 1t squared. If we factor out a negative 16, we're going to have negative 4t, since a negative times a negative is a positive. And then we're going to have a minus 5, since negative 16 times negative 5 is positive 80. All right, so this negative 16 is not really going to affect our answer right now, but we can take a look at our trinomial in here, and we should see if we can maybe factor this, because that's usually a pretty quick way to solve these types of equations if it's factorable. Now, I think in this one we have 2 factors of negative 5 that add to get to negative 4, so maybe negative 5 and 1. I'm going to go ahead and write this out, open up my binomials. I think one of these is going to be t minus 5, and one of these is going to be, let's see, t and then plus 1. Okay, so if you need to take a moment to try to factor that, feel free to do so, but I believe this would be the correct factored form here. Okay. If we then go ahead and see if we can find out when the right side would equal 0, the negative 16 is not important right now, but the opposite of positive 1 would be negative 1. So if t was negative 1, then the whole right side becomes 0. And if t here was equal to positive 5, then the whole right side would equal 0 as well. Now, we do have 2 solutions here, but in this particular application problem, if we take a look at t equals negative 1, that would be going back in time. So if we want to take a look at our picture, that would actually kind of be going back over here, and that would be in quadrant 2 or on that negative x-axis, but we didn't start off on the ground. We started off at the 80-foot platform, so we don't really care about that solution right now. What we do care about is this t is equal to positive 5, and I think that's going to be located right over here. So let's go ahead and write that as t equals 5, and that's going to be the time at which this tennis ball reaches the ground. So while we did have 2 solutions that were algebraically correct, one of them makes more sense in the context of this application word problem. So we can go ahead and conclude that it will take 5 seconds for this tennis ball to hit the ground. Specifically in that first question, when we found out the highest point, we really found a specific ordered pair. The ordered pair was really just this 2, 144, and that's also something called the vertex of that parabola. So at t equals 2, this is telling us when it's at its maximum height, and the 144 tells us the actual maximum height. And in part B, for the separate question here, we just figured out another ordered pair here, which is basically going to be 5, 0. And what the significance of that is this 5 is telling us that at time 5, the height is going to be 0, or when that ball hits the ground. Alrighty, so there we have one practice problem dealing with projectile motion. We use the AOS to find out the time for the maximum height, and then we plug that in to find out the actual maximum height. And then we solve the quadratic equation, setting the height equal to 0 to find out when the ball hits the ground. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and letting me know in the comment section down below. Now, if you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or 2 who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.